Welcome back to the second section of Chapter 2. In this section, we're going to be looking at proportional reasoning. We're going to be solving proportions and using proportions to help us solve problems. This is another topic that you'll probably remember a bit of from Algebra 1, but we will be looking at it because we may be throwing extra twists in it that you haven't seen before. So we have a learning target for today. I can apply proportional relationships to rates, similarity, and scale. So a proportion, what is a proportion? A proportion is just a ratio equals a ratio. A ratio is just a fraction, so a proportion is just a fraction equals another fraction. To solve these, we are going to use what's called the cross product property. And what the cross product property says is if I have this proportion, a over b equals c over d, then I can use cross products, a times d equals b times c. So I can multiply sideways, a times d equals b times c. And so, in solving proportions, that one's not supposed to be there yet. Ignore this for now. In solving proportions, you might be thinking, I know how to do this. Cross multiply and divide. No, not particularly. Sure, cross multiply and divide works for the easy problems, one that you saw in middle school and Algebra 1, and things like that. So a problem like 6.4 over x equals 2 over 3, yeah, cross multiply and divide will work. So we can cross multiply. So 3 times 6.4 and x times 2 to get 19.2 equals 2x, and then divide. So divide by 2, x equals 9.6. Cross multiply and divide works for those easy problems. But for something like this guy over here that we can now pay attention to, it doesn't work out so well. Sure, we can cross multiply. 9 times 2 equals 6 times u minus 5. But then divide doesn't particularly make sense at this point. We could divide by 6 in this case because 18 is divisible by 6, or we could also distribute. And so instead of cross multiply and divide, cross multiply and solve. Solve may be more steps than just a division step. And so to solve this, again, we could divide by 6 and then have 3 equals u minus 5, add 5, or we can distribute that 6, add 30, so you get 48 equals 6u, divide by 48, or divide by 6, and we get u equals 8. So cross multiply and solve is how you want to solve the proportions, because they'll have things like this. We may have variables on both sides of the equation. We may have a lot of things, but really it's just the way the equation is set up. We can solve it like any other linear equation. To set up a proportion, because a lot of the proportions you're going to get aren't just going to be set up for you. Proportions are fantastic in real-world situations, which means that we're going to be using them for word problems. So, an example, a college brochure claims that 24% of students attending the college are majoring in business. If there are 420 students at the college who are majoring in business, how many students attend the college? And so we're going to have two fractions. When we set up these fractions, we need to make sure that pieces stay the same. In this case, I'd want the part divided by the whole equals the part divided by the whole. So we have two things. We have a percentage. 24% of the students are in business out of the whole 100%. And then we have the actual students at the college. 420 students are the part out of the whole student body attending the college. And so we have part and whole. 420 students out of everybody, which we don't know. One of these is a variable. Equals and 24% out of 100%. Now we can cross multiply. 42,000 equals 24x. Divide by 24. X equals 1750. So in this case, x equals 1750 isn't actually the answer. 1750 students at the college would be the answer. The numbers have meaning in the beginning. They need to have meaning at the end, too. So you have to give them back their meaning. Setting up another one. A surveyor uses similar triangles to measure the distance across a canyon. What is the distance across a canyon according to the diagram? And then here we have our diagram. So this is a similar triangles problem. Similar triangles are nice ratios. So in this one, we have right angles here and here. Then we need to figure out, all right, so what sides go with what sides? So we know that those angles are the same. Well, we have vertical angles here, right? Vertical angles are just across the angle from each other, and we know those are equal. They're congruent. And so we have the sides in between the right angles and the vertical angles. So the 22 and the 77 are together. And then we have the other side, because the hypotenuse would be the other one, but we're not using the hypotenuse. But then we have the 15 and question mark. So we can set it up. There are lots of ways we can set this up. We can go purple over orange equals purple over orange. We could go orange over orange equals purple over purple, as long as we keep like the small triangle over the big triangle, or the big triangle over the small triangle for both cases. So there's a lot of ways that these can be set up correctly. In this case, we have orange over purple equals orange over purple. Why did I choose this way? I started out with my variable because I just want my variable on top. It's easier to deal with than when your variable's in the denominator, because now we just really need to multiply by 77. I will cross multiply here though. Get 22x equals 1155. Divide by 22. X equals 52.5 feet, because it's a unit, and so we want that feet there. And another one. Oh, no, not another one. I was going to have another one here, but I could not get the map. I couldn't make a copy of my map. So people say, like, well, how am I going to need to use this to cross a canyon? You know, I've actually done that before. I had to figure out how far it was across a little ravine because I was building a bridge across it in Boy Scouts. And so I actually used my math when I was in high school, by the way. But other than that, a few years ago, we built a house. I didn't actually build the house. I paid people to build the house for me. That's why it's still standing. However, we had extra trees, and I needed to build woodsheds, which I actually did build by myself. And so the problem is I had a tree where I wanted to build the woodshed, so I had to take down the tree. This was a tall tree. It couldn't go one direction because it would have destroyed a fence I just built. It couldn't go the other direction because it would have gone into the road. And so there's really only one direction that I could take this tree, and that was towards the house. I had to measure how tall the tree was using its shadow, me, and my shadow to make sure that when it fell towards the house, it would not hit my house. And so using this same thing and a lot of overestimation because I wanted to make sure that it wasn't going to hit my house, I actually measured how tall the tree was. And I had room, and the tree came. It came towards my house, and it did not hit my house, which is one of the reasons why I'm still married. So anyway, I will see you for the next section.